Hello everyone, welcome back to Quick Coding Bites. Today we will continue our journey in fundamentals in programming with a discussion about pointers. What are pointers? A pointer is a programming language object that stores a memory address. A memory address can be the address of something else such as a large array or other data structures, or integers, booleans, and other programming language objects. Some programming languages don't have pointers available for coders, but pointers are the underlying reason for why your operating system and virtually any large project which uses a lot of memory works efficiently. We'll be looking at a very simple example for the use of pointers. Though this example may not completely do justice to the power of pointers, it is a good way to start learning about them. To start, let's first write a function which swaps two numbers without pointers. So let's void swap. We're not going to use pointers for this, and we'll see that this function actually won't work, and we'll discuss why it won't work, and then we'll fix the function using pointers and see the power of pointers. So let's create a temporary variable. Temp is equal to A is equal to B is equal to temp, and then that's it. Let me take this extra space out, extra couple spaces, and then so when we go into main, let's create int x is equal to 5. Let's make int y equal to 7. Let's print them out beforehand. So x tab y. Let's swap the numbers. So swap x, y, and then let's copy this line over, and let's run it and see if it works. It won't work, and we'll discuss why. It's taking a while to build for some reason. So as you can see, as I said, it didn't swap them. So let's look at the memory model and how this works behind how the memory is structured to see why it doesn't work. I'll give you a hint. The main reason is because the function is passed by value. So let's draw the memory of this function out of this code out. So we originally create two variables, x and y. So x. So to represent these variables, I'm going to draw a box with their name on top. And this will become relevant later. I'm going to also write a memory location. So I'm just going to make up a memory location of the variable. So let's say it's in variable location 6. So let's see what the value was. It was 5 and 7. So x is 5, and it's in location 6. Y is a value of 7, and it's in location 12. And so we declared the variables as such, and then we print them, and then we swap them. So when we swap them, we pass by value. We actually take copies of these variables and we insert them into the function. So how it looks is actually like this. So we have another variable called a. Its location, let's say, is 15, and we have b, and its location, let's say, 17. Well, when we pass by value, we pass the actual value over. So we pass this over, we pass this over. So this value is now 5, this value is now 7. And then the function runs, so we create a temporary variable called temp, and we set a equal to b and b equal to temp. So let's do that here. So I'm going to represent temp with the t. And let's say it's in memory location, let's say 3. So we set temp to equal to a. So this is 5. The value of A gets switched to B, so that's 7. And then B gets switched to temp, so that turns into 5. And now we leave the program, we return. And all of these are local variables. That means once we leave the function, all of them get removed. So essentially, all these variables, they're gone. They're gone. So we didn't actually change the original variables. So we need a way where we can pass in the actual memory locations of these functions. And if we were able to do that, then maybe we can somehow access these values from these memory locations and change the actual value of the variable. In come pointers. So pointers will be the answer to this problem. So I'm just going to remove this function, and I'm going to remove this too. So let's first figure out how you can declare a pointer. So I created int x is equal to 5. Now I'm going to create a pointer. So the syntax to create a pointer is you write int against, because I want to make a pointer which points to an integer, and then you put a star. So a quick note about the star. The star here is just a special symbol that you attached to the integer part to create a pointer. But as we'll see later on, the star is actually an operator that's used with pointers. But in this case, it doesn't act like an operator. It's just syntax we use to declare a pointer. So I'm just going to write IP for integer pointer, and boom, I declared a pointer. Now let's create this pointer. Let's actually make this pointer point to something. So I just want to point out how this looks in the memory right now. So let's clear this real quick and take the black pen. So we have x. Let's just see what the value of x was. X is 5. So the value of x is 5, and let's say it's in memory location 7. Well, we created a pointer, right? So we created IP. And let's say it's memory location 15. That's all we've done so far. Hey, we don't know what value it is. So now let's give it a value. So to give a pointer a value, a pointer, as I mentioned earlier, holds a memory location. Let's make pointer hold the memory location of x. To do that, this is the syntax. IP is equal to ampersand x. Now you just learned your first operator. Your first operator that you learned is ampersand. So ampersand actually means address of. It means address of. It means it's the address of. That's all ampersand means. In English, it means the address of. So what this line says is IP is equal to the address of x. So in memory, it means this value is equal to the address of x. So this value is equal to 7. Now, let's say we want to modify the value of x using the pointer. Now, how would we do that? So in comes the second operator. The operator I was talking about earlier, the star operator. So again, I said here it's just a symbol, but now we're going to actually use the operator to do something. So I'm just going to write the line and then I'll talk through it. So the star operator means when you do star with the name of a pointer, it means the value of the thing that's being pointed by the pointer. Now, that sounds a little complicated, but essentially it says, if we go to the memory model, it says, okay, we look at the value of IP. It's 7. We know that's a memory location, so we're going to go to that memory location, and then we're going to change that variable's value. So what I did essentially here is when I do star IP is equal to 14, what it does is it looks at this value. All right, it's at 7, so I'm going to drive all the way to the memory location 7, and I'm going to change its value to 14. And that's all pointers are. Those are the only two operators you need. So The other operator is the star operator, and the star operator, for a lack of a better term, is the value of the variable pointed by the pointer. It sounds a little complicated, but that's essentially what it is. It's the value. Uh, it's the value of the variable pointed by the pointer. And there's a quick note that I would like to give, that we created pointers for integers here, but in fact we can create pointers for any other data type. So now let's make a character pointer. So let's remove this. Let's make car C is equal to A, right? And let's make a pointer. So again, the first time you put the star, it doesn't act like an operator. It just is a symbol that we do CP is equal to ampersand C. I'm just going to reiterate it, so I'm going to draw the memory model again. So actually, I'm just going to draw it underneath here. So we created C. We did this. Let's say its location is 2, and it's A. Right? We created a CP, a character pointer. Let me just, yep, A, and then let's say its location is 15, and we made it the address of C, so we made it 2. And now, if we wanted, we can modify it using the star, so let's go ahead and do that. We do star, we do star of CP is equal to B, and now we modified this to equal to B. And let's actually print it out to show. So let's do cout C C, and then C end line. Let's just copy this line over here, and then let's start with the debugging. So C, and then we switched it to B. So one thing to keep in mind is that a pointer can only point to a data type of the pointer. What I mean by that is I can't declare an integer pointer and let it point to a character. So if I were to put int here, you'll see the compiler throws an error. Throws a value of character pointer cannot be used to initialize an entity type of int. So integer pointer is a pointer to an integer only. A double pointer is a pointer to a double only. A float pointer is a pointer to a float only. And a character pointer is a pointer to a character only. Another point that I would like to make is the actual data type of the value of all pointers, whether it's integer, float, character, or otherwise, is the same. It's a long hexadecimal number that represents a memory address. The only difference between pointers of different data types, so the only difference between character pointer or integer pointer is the type, or is the data type of the variable or constant that the pointer points to. So to show that, what I'll do is I create an integer. I'm going to create an integer pointer, and I'm just going to do that. And I'll do. Let me remove some of this. So I'll just do this, and here I'll remove that, and then let's just print. Let's do C for character, and then size of the CP, and then let's create a tab, I for integer, and then size of IP. Right, and let's run this. gonna take a little bit. I don't know why it's taking so long. But as you can see, 8 and 8. So even though in reality it's a character and an integer, since they're pointers, they're always gonna be, they're not always essentially 8 bytes, but they're always a long hexadecimal value. So now that we learned about pointers, why don't we try to rewrite the swap function so it uses pointers and it actually swaps the two numbers that we want. So let's go back here and let's clear this all out. And let's determine what we want. So let me redraw this real quick. I have A, let's say its value is 7, its memory location is 12. We have B, whose value, let's say, is 3, and its memory location 19. Well, what we want to do is we would want to create a pointer. So let's say this is X. It's a pointer. I'll put you know what? I'll use a different color. I'll just put a dot here to represent it's a pointer. Let's see. So we're gonna, and let's say its memory location is 17, and we want its value to be 12. Oh, whoops. We want its value. We want its value to be 12. And now we create another one. Dot Y. And we want its value to be 19, and let's say it's in memory location 30. The reason why we want it to be 19 is because we want it to point to B. And now what we can do is we can now create, let's create a temporary variable when we do the swap function. So now we're going to use these to swap. Let's create a temporary variable, T. Let's give it the value of X. So we'd give it the value that's pointed by X. So again, this is going to use the star operator. We go to memory location 12 and take its value and put it into temp. So make this 7. Then what we do is we take we go to location 19 and we take its value and set that equal to X. So we would set that equal to X. So make this 3. And then we would go to Y. Again, we take this memory location, set that equal to T. So then this would this would change this to 3 because we want to go to that memory location. And then we want to go to this memory location and set that equal to 7. So let's see what happens programmatically. So we write the swap function again. Again, we can be void. We do swap. Now we're going to create two pointers. So we're going to do int star x, int star y. And now let's create an int temp. And what do we want? We want the temporary variable to equal to the memory location pointed to the value of the memory location pointed by x, which is 7. So what would we do here? We would do star of x, because again, star of x does this. It looks at, oh, I have to go to memory location 12 and take the value of that. And next, we want the value that's pointed, we want the value of the memory location pointed by x to equal the value of the memory location pointed by y. So we want, we go to memory location 19, grab its value, and put it back into the value that's pointed by memory location 12. And then we want the memory location pointed by y to to equal temp. And let's return. And now, when we call the function, so let's first create them real quick. Int a is equal to 5. Right, is that what I called them? Int a is equal to 7 and 3, actually. Int a is equal to 7. Int b is equal to 3. And when we swap them, so here, when we swap them, we want to pass the address. We want to pass the address. We have to set these equal to the address of these two. So we're going to use the ampersand. So swap the address of A and the address of B. And so let's see out A, tab, B colon, B and line, and then let's copy this over here. And now let's run this. And voila, we swap the numbers. So that's essentially the power of pointers. Though we did a simple example, you can clearly see the benefits of using a pointer. If we create a pointer which points to an array, for example, of 1,000 integers, and we want to pass it to functions, it'll take a lot of time to copy each integer over to another place in memory, and it'll obviously take up a lot more memory. With pointers, you're only passing over a single number, which can happen instantaneously. So that's why pointers are so powerful. Hopefully, now you have a good understanding about pointers. Stay tuned for more videos.